Look at the first part of the word. What's that mean?
One.
One. So it's basically one term. So this means one term. Versus polynomial, first part of the word poly means multiple or many. Okay, so when a monomial is simplified, okay, and in turn we'll look at polynomials, there are no powers of powers. So it's almost easier to think of like what you can't have than what you have. So for example, if it was like x squared and then to the third power, that's not simplified, right? We can simplify that further by multiplying the exponents. Each variable appears only once. So in other words, I wouldn't have like a 2x plus 4x plus y, right? Because I would want to have those combined, right? So each variable appears only once. All fractions are in simplest form. So we don't want to have 12 over 24. Okay. No negative exponents. So I can't have x to the negative 2 or y to the negative 3. What's x to the negative 2? Is there another way we could rewrite that? Remember what happens if you have a negative in the exponent?
X.01?
Something about taking, do you remember if you have a negative?
Is it y power 2? Oh.
If it's a x to the negative 2, we can switch that to make it 1 over x squared. Does that look familiar? No. Okay. Somewhat. All right.
Makes sense.
Just these two are the same. These two mean the same thing. So I say no negative exponents. You also can't have a variable in the denominator. There are no roots of variables. So you can't have like a square root. So all of these are things that you can't have. Okay, so what are some examples of a monomial? Okay, it could just be a number. It could be 1.
So each variable only appears once. You can't, like, what do you mean, like, you can't?
So a monomial,
it's just like each thing only appears once. Like that's
right,
true.
so you would want it to be like 6x would be an example of monomial.
Yeah.
Or 2x squared y.
No, like what I'm saying is like it says I can't have, but
Yeah, you
that's
can't have, these aren't simplified. So again,
I'm looking at the wrong thing. Okay, never mind.
sorry, these are things that are simplified, and so I was giving you like non-examples
Okay.
because these are things that you can't have, and then these are examples of what you can have.
Okay, got it.
Okay. Now, polynomial is a monomial, or it's the sum of monomials. So it could just be negative 2x.
Is that a y after 2x?
Oh, yeah, that's a 2x squared y.
Can't you not have it?
You can have that. Here's the key. With a monomial, you can't have a plus or a minus sign in between things.
But doesn't it say each variable appears only once?
Yes, I meant this part right here. Sorry. That's what makes it. You see,
Yeah.
you would want that just to be a 6x, not 2x plus 4x. What would be another example? Or do you have a question, Owen?
Would that be x to the power 2?
You could do x to the power 2. How about x to the power 2 plus?
Yeah, but there's no powers.
No. No powers. Where are you looking at? No powers of powers. You would want to make that x to the 6.
No powers or powers.
So listen, we're talking about a few things here. We're talking about what is a monomial, what's a polynomial, and in addition to that, what does it mean when it's simplified? Okay, so there's really kind of 3 ideas going on all at once here. A polynomial, so this is a monomial. This would be a binomial because there are 2 terms. We could have a trinomial, which has 3 terms, right? So you could have like 4x squared plus 5x minus 6. Right? I have three things separated by a plus and a minus sign. Does that make sense a little more?
Yeah.
Mhm.
Okay. Now, how do we find the degree of a monomial and the degree of a polynomial? Well, if it's a monomial, you basically look at all the degrees added together. So we're going to take the sum of the degrees of each variable. So for example, let's take that 2x squared y. What's the power of y? 1. So if I were to add the exponents here, what do I get? 3. So this has a degree of 3. Right? Actually, if we look at these other monomials, what do you think the degree of 1 is? 0.
Oh, yeah.
This has a degree of 0, because what's the degree of 6x? What's the degree of x? 1. All right. So this has, so anytime you have a constant, just like a number by itself, the degree is always 0. Yeah, Owen?
Wait, how is the degree of 2x squared y 3?
So this has a power of 2. This has a power of 1. So we add the exponents together. See, some. Okay. Now, if you're looking for the degree of a polynomial, you basically look at the degree of each term and take the largest one. So let me give you an example. How about 3x squared plus 2x to the 5th minus 8?
That would be 5.
It would be 5. Okay, so I look at each term. This has a degree of 2, a degree of 5. This one is 0. So this has degree 5.
Wait, how?
The largest exponent right here, that's the degree of the whole thing. So it doesn't necessarily have to go in order. This is a smaller exponent than this one. We just want to take the largest term.
Then
Well-
why doesn't the one above, why isn't it 2?
Because I had a y to the first also. Let me give you another example. How about if I said 2x to the 3rd y squared plus x to the 4th y to the 5th plus x to the 7th.
9.
Right? So look at this degree. This one is going to have a total of 5. This one, the exponents add up to 9. And then this one just has one exponent, so that just means that part is 7. So which one had the largest one term? The 9. So that's the degree of this one. Is that a little more clear?
Yeah.
Okay, state whether each is a polynomial. If it is a polynomial, let's state the degree. What do you think for A? We have x over y. What's the problem here? There's a, yeah, technically this is x times y to the negative 1, which, right, because when we have variable in the denominator, that implies a negative exponent. So we just say no. Okay. If it's not a polynomial, there's no degree to it. So we just skip, right? We only answer that second part if it's an actual polynomial. Because when there's a variable in the denominator, that really means it's a negative exponent, which we can't have. So remember this rule here, no negative exponents. I gave the example of x to the negative 2, which is really the same thing as 1 over x squared. Just think anytime you have a variable in the denominator, it's also not going to work. Okay, how about the next one? So yeah, this has a degree of 6, 7, and 2. So what's the biggest one?
7.
Okay, and we forgot to write, the first part is yes. Do we have any negative exponents? No, we don't have any. So this is a polynomial. And what did we say has a degree 7? Okay, good. Questions? Okay, next page. Again, I know Algebra 1 was a while ago, and it was on Zoom for some of you. Some of you. Okay. Do these look familiar? When you have, no, this doesn't look familiar?
Somewhat, yeah.
When you have, like, let's say, I'll give you some examples. So let's say the first one, if I have x squared times x to the fourth, that becomes x to the 6. So when you have the same base, you add the exponents. Because think about this. What's x squared mean? You have x times x, right? And then what's x to the fourth mean? You have 4 of them. So how many total do you have? 6 of them, right? So it makes sense that you add those exponents. Okay, quotient of powers. So if I have x to the a over x to the b, we subtract the exponents. So I'll give you an example. X to the 9th over x to the 5th becomes x to the 4th. Right? The same kind of idea as this last one. I could do x times itself 9 times and x times itself 4 times, and you would be able to cancel, and how much would you be left over with? Okay, negative exponent, that's what we just had mentioned. So if I have x to the negative 4th, that becomes 1 over x to the 4th. Now, what's the difference between power of power and product of powers? Sometimes we get these mixed around. It's on the outside. We're multiplying. So this would be, for example, if I said x squared raised to the 3rd power, that becomes x to the 6th. Why? Well, we have 3 x squareds. Oh, am I making it too small? I can make it bigger, sorry. Or make it a little more clear. Maybe it's the color. I should use a darker color. And how about this one? We're just, this is kind of like you distribute. Like, for example, what if I gave you 2x cubed and then I said to the 2nd power? I don't just take the x to the 3rd and square it. I also have to take 2 and square it. So what happens when I have, right? So it would be like 2 squared times x to the 6th. So you can't forget about the coefficient, right? We're multiplying to both. Because technically, what's the exponent of the 2?
4.
But right here, isn't that just a 2 to the 1st power?
Oh, yeah.
So if I multiply it, I get 2. That's how I get 2 squared, in other words. What's that? You got it? Okay. This one, same thing as the last, but with a quotient. So let's say if I had x to the 4th over y, and I square it, I have to take the numerator and the denominator. So what's that going to look like in the numerator? You're just going to multiply it, right? Anytime you see parentheses around it, you're going to multiply the exponents. So what does x become?
X to the 8th.
Wait, multiply though.
X to the 8th times y squared.
Oops. So, my pen's not working again. Okay. What happens in the numerator? We have parentheses, so that means we have to multiply it here. So x to the 6 on the top. Now be careful. This is what in the bottom? 27. Why? Technically, that's 3 to the 1st power. So if I multiply these exponents, isn't that 3 to the 3rd?
Yeah.
And that's the 27. Good. Okay, last one. Anytime you have a 0 power, equals 1. That's all. So I can make the whole, I could have like 3xy to the fourth. And if I put a 0 on the outside, the whole thing's just equal to 1. Okay, questions? I know those were a lot of rules there. Okay. All right, so when we simplify, we're going to get rid of parentheses. We're going to combine any like terms, get rid of any negative exponents. Okay, so those are kind of the 3 rules here. 3 halves to the negative 2. What do you think?
2 over 3 squared.
Okay, so we're going to flip it first. So we'll have 2 over 3 to the second power. And then remember, what do we want to do? We want to distribute to both parts. So what's that going to look like?
4 over 9.
4 over 9. And can we reduce that?
No.
Nope. So we're done. Okay, n squared over n to the 10th. Okay, which one does this look like? This looks like the second one, quotient of powers. So what can I do to simplify that? And actually there's a couple different ways. You could do 2 minus 10, which gives us what? Negative 8. Now I don't want to leave a negative power, so how do I rewrite that?
1 over n.
Good. Does anybody know of a different way that you could also look at that? If we divide by 2, would we get 8 though on the bottom?
Or like square root or something. So that would become like n over n.
We are going to work with what you're technically talking about is rational powers. We're not there yet. But could you have look at like which one is bigger, the top or the bottom? The bottom. So if I just take 2 from 10, I get n to the 8th in the bottom. Does that make sense?
Mm-hmm.
So I'm actually okay if you don't show any work for something like that. See, what do we notice?
1.
Yeah, the 0 power, so the whole thing is just 1. Okay, questions so far? Because we just have more of these simplifying. I think that's it then, just this page. Okay, now it gets a little messier. Now these have parentheses, but are there any exponents on the outside of the parentheses, like right next? No, so technically this is where we're going to add exponents. But we also have a 2 and a 3 here. So what do you think we're going to do for those? We're going to multiply. So we're going to multiply. So this is an example. We're going to multiply the 2 and the 3. That gives us 6. But we're going to add exponents. Okay, so let's look at the A's.
So just be 6 again.
Yeah, a to the negative 2 and a to the 3rd would just be a to the first power. Then we have, is there anything to combine with the b squared?
No.
No. And is there anything to combine with the c to the negative 2?
No.
We have to change
But
that.
I have to change what?
Yeah.
I have to move the c to the denominator?
Yeah.
What about the 6? Do I move that around? No. So technically 6 has a positive 1 exponent. So we're going to leave 6ab squared over c squared.
Oh, because it's multiplied by 1. How'd you get 2 for
Okay. Did you get this part? You have a to the negative 2 and a to the 3rd. Add the exponents, so that gives us a to the 1st. But then there's a b squared. These are all getting just multiplied together. So I'm looking for any other b's to combine. There is nothing, right? So that's the b squared. And there's nothing else to combine with the c to the negative 2. So I just move that to the denominator, but all of this stays in the numerator. Okay. All right, how about b? Okay, what do we have? We have -2 to the third, right? We're going to distribute that power of 3 to each part. What happens with a to the fourth raised to the third power?
It becomes a to the 12.
Good. Remember, we're multiplying exponents. Where's the exponents? On the outside of the parentheses. What's the power of -2? 1. So, right? And then what do we get in the denominator? Multiply here.
B6.
Good. Now I just want to rewrite that first part of the problem. What's -2 to the third? -2 times -2 times -2? Good. Do I have to move the -8? No, because that's not an exponent, right? That's a coefficient. Right? We only move them to the denominator if the exponent's negative, not the actual number. Okay, so we have a variety here. This is probably an easier problem because we're just subtracting two polynomials. So I'm just going to rewrite this as -x squared minus 3x plus 4, just kind of removing the parentheses. And if I'm subtracting, I want to just make sure I'm subtracting every part of the other polynomial. So I have -x squared minus 2x, and then what? Plus 5, good. Can I combine some like terms here? Yeah. What do we have?
X squared and X squared.
Okay, so x squared and x squared, so that'll be minus 2x squared. Minus 3x and a minus 2x.
Minus 5x.
Good. And lastly, plus 4 plus 5. Good. Okay, next one. Just multiplying it out, right? So if we distribute, that's what I said. And when you see a variety on your homework, some will be, I think these are kind of a little more complicated, but then this is just like distributive property. What do we get when we multiply 2x to 3x squared?
6x cubed.
Good. Minus?
12x.
Good. Oh, and there has to be a fraction. It's okay. It all works out nicely. Is it a perfect square without a fraction?
Without fraction.
You could have a perfect square with a fraction, but... Okay, let's see what happens when we multiply. What happens when we do 4/3 times 6? 8, good. And what's x to what power?
X to the 4.
Good. Plus 4/3 times 9. 12. And x to what power? 3, right?
Yeah.
Okay. And 4/3 times 12.
4? 6.
Well, 3 goes into 12 4 times. 4 times 4,
Oh.
16. And then it's just x squared. And you don't have to, this is not factoring, okay? So if you notice something that you can factor out, that's not this lesson, right? The whole point of it was to multiply it out. Okay, this one gets a little crazy with the negatives. Let's see. Oh, we can do this.
Oh, that's a massive term.
Okay, let's see. I always like to put the coefficients in front. So we're going to multiply this to this. So I'm going to put the -3. And then let's do a. So -3. Oh, and +3.
Cancels out.
It cancels out. It just becomes a to the 0, right? And how about b? We have a squared and
So it'd be
B to
cubed.
the-
one. Good. All right, distribute here. So I'll put the 4 again, the coefficient in front. Okay, I have a to the negative 3 and a squared. So that's going to be a to the, good. And what about b? I have b squared and b to the negative 1. So just 1. And last, so I have a to the negative 3 and a to the first. A is negative 2. And how about the b? B to the 0, so that just ends up being 1. I'll just write it out so we can see. Now, I want to get rid of anything that's a negative exponent. So what am I, and I want to get rid of all the ones that have 0. Sorry, Lily, can you see? So what's the first term going to be? Negative 3 b cubed plus, okay, that one has a negative exponent, so something's going to go on top, something's going to go on the bottom. The only thing that goes in the bottom is,
4, right?
okay, but what's the exponent for the 4?
1.
Isn't that a positive 1 exponent for the 4? So the 4 stays on top. Don't forget, leave that 4. So it's going to be 4b on the top. The only thing that moves to the bottom is the a. This 4 is not necessarily attached to this a to the negative 1. That 4 is something separate. Okay, next, minus, same thing here. Is that 5 a positive 1 exponent or a negative 1? It's a positive 1, so it stays on the top. And what goes on the bottom? A squared. And what happens to b to the 0? Just goes away. There you go.
That's a lot of work.
Oh, got a lot of work here. Okay, don't worry.
Wasn't too bad.
That wasn't too bad.
Well, I mean, I've done worse, but.
It's just a little practice. It's okay. What about the next one? Oh, it's not that bad.
You just have to add data.
Okay, so we can't just do FOIL because this is a trinomial and this is a binomial. So what I would probably do is just distribute. So let's take x squared and multiply that to the binomial. So when we take x squared times x, it becomes x cubed. And then x squared times minus 4, so minus 4x squared. All right, next. Now I'm going to take 4x and distribute that.
Why wouldn't you do x minus 4 to 16?
We're going to do that last. I'm taking this to multiply each part, this to each part, and then that.
I was thinking the other.
You know what? You can go the other way. You'll get the same. We'll get the same answer. So it's going to be plus 4x squared minus 16x. And last here, right? Plus 16x minus 64. Oh, looks like a lot of this stuff cancels. So what do we get? X cubed.
Minus 64.
Okay. All right, now we got 3 binomials multiplied together. However, what do we notice about the first 2? Do you remember what those are called? Conjugates. I know, it was a hard one to remember. Conjugates. What's important to know about something that's like a plus b, a minus b when we do FOIL? But what happens if we FOIL this? It's just a squared. What happens when we do the outside? Minus ab plus ab. So we're just going to have the first, oops. So it's going to be a squared minus b squared. And then we'll bring down. So what it ends up turning out to be is just another FOIL. Okay. Does that make sense?
Mm-hmm.
Yeah.
Okay. All right. So what do we get when we multiply? Do you want to give it a try? Guys are so half asleep here.
I'll do it.
You want to try it? Okay. All right. Juliet's going to do it. Oh, we got a messy fraction 1 coming up at I, and then a C minus 2D to the third.
Ooh, I'm like, how do I erase?
Oh, the bottom button here, hold it down.
Okay. Goodbye.
Oh, what happened?
I did it.
Okay, so we should get, good, 2A to the third, good.
First, outside,
Minus
3,
3 A squared B. How about that?
first, outside, inside.
What happened?
Did I do it wrong?
Something's wrong.
Oh no.
There's
What happened? Help her out. Help her
No,
out.
it's
Two A cube. One of them is wrong.
One of them's wrong.
One of the two A cubes.
Okay, this 2A cubed is fine. Minus 3A squared B. Oh, this should be, oh wait. Oh, this one
Two
here.
A B.
This should be, I know what you did. I think you accidentally thought that was an A squared. So make this
Wait.
minus,
First,
so it's this
outside,
one.
inside. Oh, yeah, no, you're right, you're right.
So erase the 2A cubed and put, what does she want to have?
Negative two A B squared.
Negative 2AB squared. And then, is there anything, so
Everything else is right.
everything else is fine.
Negative
So
2
minus 2AB squared.
AB.
And then is there anything that we can combine?
No. Oh,
Nope.
yes.
Oh,
Alright, that's
Is there?
Negative
And
three A.
then plus
Is there?
3B.
Yeah.
no, these are opposite though.
Oh.
Right, because this is A squared, this is B squared. Remember, they have to have the exact same combination of variables.
Has to be
and
the same
exponents.
order?
Yeah.
Okay, so then that's the final answer.
What happened? What happened? What did you say? Bud?
I said your air looks good.
Oh,
Does that look like it's Dyson air?
Dyson
it's
Airwrap.
not. Thank you.
How? You just grab it?
Flat iron.
Oh.
Mhm. Okay,
I really need to
who wants to try? Is the next one too scary? Anybody want to give it a try? It's not that scary.
Actually, no,
Oh my
I'll-
goodness.
I think we should, I think we should,
minutes, so.
I think we should go last. We just go last.
It's doable, it's just will take a while.
Okay, I'm going to flip everything first and make it a positive 3 on the outside. So 3x to the negative 4. Now, could I simplify the inside?
Probably somehow.
3F.
Yeah, of course.
Wait, what?
Okay,
Oh, you're
I'm
flipping.
literally flipping everything and just making it a positive 3. Oh, it's already 12:38. I know.
Join everything. Not that.
You're like, it's lunch. Finally. Okay, what would we do from here? Anybody have a suggestion?
Distribute.
Do you want to distribute and then simplify, or simplify and then distribute? It doesn't matter.
How would we? Oh, because the top and the
I already set up
bottom.
the front.
Distribute.
So you want to distribute it?
I think we simplify
Yeah.
first.
Okay. It doesn't matter. It doesn't matter. It really, it's like,
You already get that.
I got them in 10 seconds.
okay, 3 to the third, right, is 27. Multiply these, negative 12, multiply these, 15. 2 to the third. Just remember with the coefficients, you have to raise them to the powers. X to the 6 and then y to the negative 9. Okay, now we're going to subtract the exponents. I'm going to leave the 27 and the 8 where they are. You can't simplify those anyway. Okay, negative 12 minus 6 will be negative 18. So what will that mean? You get x to the
X over 18 and then the
x to the 18th on the bottom. Did that make sense?
Yeah.
Yeah.
Okay, and then 15 minus negative 9, so that makes it 15 plus 9,
It's 24.
24, and that goes on the top. Okay. All right. I will put in the last one if you want to just look and see. It basically means you just have to multiply it out 3 times. Okay?
Lovely.
I'll put the answers up online, but otherwise, I think you guys are